Hey everyone, in this video we're going to learn how to graph parent functions in which multiple transformations have occurred. We're going to do that by first identifying the parent function and then the transformations. We have to make sure we identify the transformations in the correct order. Now, you can do it in any order, but if you watched the last video, I find it easiest to look for the scaling and reflections first and follow that up with the translations. Then after we apply all of the transformations to our parent function and get our graph, then we're going to determine the domain and range. So we're starting with y minus 3 equals negative 2 times the quantity x plus 1. So the parent function here is the linear function y equals x. We don't use this all too often as a parent function because we've graphed this line already. It's just point-slope form, where the slope is negative 2, and a point on the line is negative 1, 3. So I want to take this problem and think of it as a transformation problem, and see if it gives us the same graph. So if we divide by negative 2 on both sides, we'd have y minus 3 divided by negative 2, and then we have x plus 1, and we can divide it by 1 if that helps. So looking at our scale factor first, our scale factor is 1, negative 2. So we have a vertical stretch by a factor of 2 and a reflection over the x-axis. And then we're going to follow that up with a translation. So x plus 1, we're going to subtract x by 1, and we're going to add 3 to y. So we're going to shift it left 1 and up 3. So let's start with the table of values for our parent function, which is y equals x. So we have x, we have y, so our table of values is negative 2, negative 1, 0, 1, and 2 as our x values. And if y equals x, then negative 2, negative 1, 0, 1, and 2 will also be the y values. Now we're going to first scale those points by a factor of 1, negative 2. So we'll deal with both the vertical stretch and the reflection at the same time. And then we're going to translate those points, negative 1, 3. Okay, so first, multiplying each point, x by 1, y by negative 2, we get negative 2, 4, negative 1, 2, 0, 0, 1, negative 2, 2, negative 4. Then we're going to take our scaled points and we're going to translate them. So subtract 1 from each x, add 3 to each y. So negative 3, 7, negative 2, 5, negative 1, 3, 0, 1, 1, negative 1. Okay, so plotting those points, negative 3, 1, 2, 3, 4, 5, 6, 7, negative 2, 1, 2, 3, 4, 5, negative 1, 3, 0, 1, 1, negative 1. So there we have the points that have been scaled, then translated. So we can connect the points with a line. So there we have our graph of y minus 3 equals negative 2 times x plus 1. So let's see, is it the same thing? Well, is the point negative 1, 3 on the graph? It is. Is the slope negative 2? It is. So really, point-slope form of a line was just a transformed graph that has been both scaled, possibly reflected if it's a negative slope, and translated so that the point at 0, 0 is that point that we identified in point-slope form. Finishing off this question, the domain is all reals, negative infinity to infinity, and the range is also all reals, negative infinity to infinity. Next up, y equals negative 1/8 x cubed plus 1. So we'll start by subtracting 1 from both sides, and then dividing both sides by negative 1/8. Okay, so our scale factor is 1, negative 1/8. So we have a vertical compression as well as a reflection over the x-axis. And then we're going to follow that up with a translation of 0, 1. So we're shifting each point up 1. So again, we're going to start with the parent function, which we didn't write out. Let's write that out. Make sure we have that. So that's y equals x cubed. So we're going to start with the table of values for y equals x cubed. And then we're going to scale it by 1, negative 1/8. And then we're going to translate it 0, 1. Okay, so typically we use negative 2, negative 1, 0, 1, 2 in our table of values here. But we're going to divide the y's by negative 1/8. So I want inputs whose cube is going to be divisible by 8. That would be really helpful. So I'm going to use negative 4, negative 2, 0, 2, and 4. And we can see why when we take the cube. So negative 4 cubed is negative 64. Negative 2 cubed is negative 8. 0 cubed is 0. 8, 64. So all the y values will multiply by 1/8 nicely. So we're just setting ourselves up to have better points to plot. So let's scale each of those points. So multiply the x by 1, the y by negative 1/8, so that becomes positive 8. And we have negative 2, positive 1, 0, 0 still. Then we have 2, negative 1, and 4, negative 8. And then we're going to translate all of those points by adding 1 to each y value. So negative 4, 9, negative 2, 2, 0, 1, 2, 0, 4, negative 7. Okay, so we can plot each point. So negative 4, 9. Then we have negative 2, 2, 0, 1, 2, 0, and 4, negative 7. So we connect our points, and there we have the graph of y equals negative 1/8 x cubed plus 1. We can see that it's been scaled, reflected, and translated. So the domain here is all reals, negative infinity to infinity. The range is also all reals, negative infinity to infinity. Moving on. Next up, we have y equals the quantity x plus 3 divided by 2 squared minus 7. So we'll add 7 to the other side of our equation. So x plus 3 divided by 2 squared. Okay, so we can think of this as y plus 7 divided by 1. So our parent function is y equals x squared, quadratic. We're first going to scale it by a factor of 2, 1. So we have a horizontal stretch by a factor of 2. And we're going to follow that up with a translation of, so x plus 3, subtract 3 from the x's, subtract 7 from the y's. So we're going left 3, down 7. So we have y equals x squared. Start with that table of values. So negative 2, negative 1, 0, 1, 2, 4, 1, 0, 1, 4. So we are going to first scale by a factor of 2, 1, and follow that up with a translation of negative 3, negative 7. Okay, so multiplying the x's by 2, y's by 1, we get negative 4, 4, negative 2, 1, 0, 0, 2, 1, 4, 4. And then applying our translation, we wind up with negative 7, negative 3, negative 5, negative 6, negative 3, negative 7, negative 1, negative 6, and 1, negative 3. Okay, so negative 7, negative 3, negative 5, negative 6, negative 3. Oh, that's negative 6, not negative 5. Got to move that over one more. So negative 5, negative 6, negative 3, negative 7, negative 1, negative 6, and 1, negative 3. So connecting our points. There we have the graph of our quadratic. So our domain is all reals, and our range, working from bottom to top, the lowest y value is negative 7, all the way to infinity. Okay, so really this comes down to, can we identify the transformations? If we can do that, create a table of values for our parent function, apply the transformations in the correct order, and then plot our points. Next, we have y equals 4 times the cube root of x minus 2 minus 1. So first let's add 1. So we have y plus 1 equals 4 times the cube root of x minus 2. And we'll divide that 4 that's outside the parent function. So y plus 1 over 4 equals the cube root of x minus 2. And I can write it over 1. So our parent function is y equals the cube root of x. Our scale factor is 1, 4. Multiply the y's by 4, vertical stretch. And then a translation of 2, negative 1. So we're going right 2, down 1. Okay, so y equals the cube root of x. We want perfect cube inputs, so negative 8, negative 2, 0, not negative 2, negative 1 that is. Negative 1, 0, 1, 8. So the cube root is negative 2, negative 1, 0, 1, 2. And then we are going to scale by a factor of 1, 4. Follow that with a translation of 2, negative 1. So we have x, and we have y. So we have negative 8, negative 8, multiplying the y by 4. Negative 1, negative 4. 0, 0, 1, 4, 8, 8. And then we're going to follow that up, add 2 to the x, subtract 1 from the y's. So negative 6, negative 9, 1, negative 5, 2, negative 1, 3, 3, 10, 7. So negative 6, 1, 2, 3, 4, 5, 6, negative 9, 1, negative 5, so 1, negative 1, 2, 3, 4, 5, 2, negative 1, 3, 3, and 10, 7, 10, 7. Okay, so we have a cube root graph, so I'll start at the middle point. So there we have y equals 4 times the cube root of x minus 2 minus 1. Our domain is all reals as we go left to right. And our range is also all reals as we go bottom to top. Perfect. Next up, we have y equals 2 times the absolute value of 3 times x minus 5. So we'll divide both sides by 2, so we have y divided by 2. And inside the parent function, inside the absolute value, we'll rewrite it as x minus 5 divided by 1/3. So our parent function is y equals the absolute value of x. Our scale factor is 1/3 2. And our translation is 5, 0. So we'll start with the table of values for y equals the absolute value of x. Okay, we need to multiply x by 1/3. So let's set up our table of values so that all the inputs are divisible by 3. So we'll go -6, -3, 0, 3, 6. So the absolute value is 6, 3, 0, 3, 6. So we're going to scale by a factor of 1/3 2 and translate 5, 0. Okay, so multiply x by 1/3, y by 2. So we get -2, 12. Then we get -1, 6, 0, 0, 1, 6, 2, 12. And then we translate 5, 0, so add 5 to each x. So we get 3, 12, 4, 6, 5, 0, 6, 6, and 7, 12. So we have two choices. We can either scale the axes, or we only have 3 points to use. So I'll use just the 3 points, because that's going to happen when we're scaling and translating. Points are going to wind up going off the graph. Not everything can be perfect. So we have 4, 6, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 5, 0, and 6, 6. I'll use the line tool so that it comes out nicely. Get an arrow at the end. Okay, so start at the vertex and go up. And start at the vertex and go up. So there we have the graph of y equals 2 times the absolute value of 3 times x minus 5. And we have a domain of all reals as we go left to right. And our range, working from bottom to top, we have 0 to infinity. Next up, we have y equals 3 times the square root of 5 minus x minus 2. So I'll add 2 to both sides. So y plus 2 equals 3 times the square root of, I'll factor out a -1, and that would make this x minus 5. And then divide by 3, so y plus 2 divided by 3. And then inside the square root, I'm going to rewrite this as x minus 5 divided by -1. So our parent function is y equals the square root of x. We have a scale factor of -1, 3. So vertical stretch by a factor of 3, and we're reflecting it over the y-axis since we're negating the x. We're going to follow that up with a translation of 5, -2. Start with our table of values for y equals the square root of x. So remember, inputs are perfect squares, so 0, 1, 4, 9. So 0, 1, 2, 3. And we are going to scale by -1, 3. And then we're going to translate 5, -2. So first up, after the scale factor, we have 0, 0, -1, 3, -4, 6, -9, 9. And then after the translation, we have 5, -2. Then we have -4, 1. Not -4, +4. 1. We have 1, 4. And we have -4, 7. Perfect. Okay, so we can plot our points. So 5, -2. 1, 2, 3, 4, 5, -2. 4, 1. 1, 4. And -4. 1, 2, 3, 4. 7. 1, 2, 3, 4, 5, 6, 7. Okay, so we can connect our points. Let's see if I can make that a little smoother. That's a little better. Okay. Now, this was 0, 0. And then scaled and then translated. We don't put an arrow there. Okay, arrow only goes on one side of the square root function. Okay, so there we have our graph. Let's try one more time. Looks a little, I don't know if I can get this good. Let's see. All right, that's better. Okay, so y equals 3 times the square root of 5 minus x minus 2. So our domain, working from left to right, is negative infinity to 5. And our range, working from bottom to top, is negative 2 all the way to infinity. So our last example, graph the following function based off the given graph of y equals f of x below. State the domain and range of the function. Okay, so in red, we have a piecewise function as our parent function, which is y equals f of x. And we're asked to graph y equals negative f of negative 3x plus 1. So first thing, let's rewrite it in the form we like to identify the scaling and the translations in. So we'll start by subtracting 1 from both sides. Negative f of negative 3x. We can divide the negative 1 in front of the parent function. So y minus 1 divided by negative 1. F of, we can rewrite negative 3x as x divided by negative 1/3. Okay, so our scale factor is negative 1/3, negative 1. And our translation is 0, 1. So we have a horizontal compression by a factor of 1/3, reflection over the y, reflection over the x, and we're going to move each point up 1. So you can either write each of these 4 points in a table of values and then apply the scaling and translation as we have done previously, or you can do it on the graph. If you do it on the graph, I would do it one step at a time. So since I haven't done any on the graph, let's do this one graphically. So first things first, let's take this parent function and scale it by a factor of negative 1/3, negative 1. Okay, so we should see reflections and a compression. So we'll start with the point negative 6, negative 2. So multiplied by negative 1/3, negative 1, that's going to become positive 2, positive 2. Okay, so we have positive 2, positive 2. Then we're going to take the point negative 3, negative 2, same thing. So multiply by negative 1/3, negative 1, that's going to become positive 1, positive 2. 0, 4, that's going to become 0, negative 4. And then 9, 1 is going to become negative 3, negative 1. Okay, so I can connect those, but those are the points that have been scaled. And now we're going to translate them. So I'll go back to the blue marker. We're going to move each of those points up 1. Okay, so those are the points that we're actually looking for. I'll use the line tool. I'll make it blue. And we can connect our points. And there, in blue, we have the graph of y equals negative f of negative 3x plus 1. The domain, okay, so from left to right, we're going from negative 3 to positive 2. And the range, going from bottom to top, we're going from negative 3 to positive 3. Okay, so it doesn't really matter what transformations they give you. Take the points on the piecewise function and then scale them and reflect them first and then translate them. If you'd rather in a table of values, take the time to write each of these 4 points in a table of values and then go through the same process we went through throughout this video. The only way to get better at this is to practice. So go do a bunch of graphing with these transformations before moving into the last transformations video on writing. Click the Amazon link down below for my algebra workbook so you can practice on your own. Give the video a like, and before you go, click that subscribe button so you can see more videos just like this. Thanks for watching.